2 in biweekly, don't know why third solution isn't working. Okay, we'll discuss all those, don't worry. 4 because of DP. Yes, nice. So when you get under 50 rank, for the 50-ish rank, so 4 problems to solve करने पड़ेंगे. You'll have to solve all 4 problems. Cool. So we will look at this. The first problem, zero index array, nums, sequential if this nums of j is equal to nums of j minus 1 plus 1 in particular prefix consisting of only 0 is nums is sequential. Return the smallest index x missing from num such that x is greater than equal to the sum of longest sequential prefix. So 1, 2, 3, the longest prefix is 1, 2, 3, which is sum is 6. 6 is not in the array, therefore this is there. Okay. Thus its longest sequential prefix is 3, 4, 5 with sum of 12. 12, 13, 14 belongs to the array while 15 does not. So therefore 15 is the smallest greater than equal to this. Straightforward, direct implementation. How many of you will be able to solve this problem? Simple, just check the condition. What is the longest prefix that is sequential? Find that number. Like if the sequence is still 5, if you see the next element is decreasing and it's not equal to previous plus 1, then that's the point where you stop. You see that you need the sum till this much, which is 12, and then you can, like for every element like 12, 13, 14, 15, 16, you can, there are 50 numbers only. So 51 numbers you can check if they are in the array. Brute force direct should be enough to solve this problem. Everybody can solve this problem. I think this is straightforward, not much to discuss. Can I have a quick +1 from all of you that this is done? I think find the longest prefix, find its sum, check the array if like x is present, x plus 1 is present, x plus 2 is present, and so on. Straightforward, right? Nothing much to discuss. I think ChatGPT can solve this problem. GPT-4 can for sure solve this problem. Okay, this is where things become interesting. Let's see. So I'm trying to also explain how would I think about these things in contest, right? Because that's also important. But it's not only about the solution. How can you read the problem better and solve it faster? That's what we'll try to learn. I'm seeing these problems for the first time, by the way. You are given a zero index integers, nums, and a positive integer k. You can apply the following operations on the array any number of times. Okay. Choose any element and flip a bit in its binary representation. Flip means 0 to 1, vice versa. Minimum number of operations required to make the bitwise XOR of all elements equal to k. Okay. Yes. If you know the properties of XOR and bits, it's very straightforward, right? I think it's as simple as just adding the number to the array and then taking the XOR, finding the number of bits on in it, right? So what is this saying? Choose any element of the array, flip any bit. So basically we can change any possible bit. So I will just give a quick visualization just so that even in harder problems you can visualize this very easily. The way I think about it is there is an array ARR, like 0, 2, 0, 2, 1, let's say, and k is equal to 2. So what will happen is so these can be represented in binary representation, which means this will be nothing but 0, 0. This is 1, 0. This is 0, 0. This is 1, 0. This is 0, 1, right? This is MSB, LSB. And then you have to make 1, 0 as the final thing. So what is being asked is the XOR of the whole thing. XOR has to be equal to this. So XOR is nothing but the number of ones in every row. This is what the property of XOR says. Well, how does XOR of an array gets calculated? XOR is the parity of ones in each row, right? The odd number of ones leads to 1, even number of ones leads to 0. So right now the XOR is 0 and this bit of the XOR is 1. We have to convert it to this. So even if we change any bit over here to 1, this will become 0. If we change any bit over here to 0 to 1, this will become 1, right? So essentially, in the original array, whatever was the answer, to convert from over here to here, the number of positions where there is a mismatch, I can change any of the bits inside the original array and that will flip that particular bit. So just simply take this XOR, take this k and find the number of mismatch bits. And that you can also find directly by using a XOR, that A and B, the number of mismatched bits in this is nothing but A XOR B number of ones in this number. Find A XOR B, okay? Because let's suppose there is 1, 1, 0, 0 and then 1, 0, 1, 0. So if you take A XOR B, this will be 0, 1, 1, 0. So you can see that wherever there was a mismatch of bits, those positions will get 1. So number of ones in the A XOR B will give you the number of mismatches, which means the number of ones that needs to be introduced or number of flips that needs to be introduced. So simply, the whole array XOR you can find, take the XOR with K and the number of ones in that. You can use C++ internal function built in pop count. I hope all of you know this. There is this function called built-in pop count, which you can use. This is a C++ function, which you can use to find the number of ones in a particular number in its bit representation. So you can just put this function. That will do the trick. Clear, everyone? How much percentage is clear? Should be, I think, this much only. I think so. Oh, I have to check on this. No, run code. Let's see. That's it. Right? It hardly takes 2 minutes to code max to max. If you understand this very quickly. Okay. So you have to know two atomic things. Think about whole arrays or flipping one thing changes just that one bit, and then how many bits differ. You can use XOR again. So okay. Very small code. Yes. So that's the difference. This is the difference between people who are able to do it very fast in the leaderboard and people who are taking it more time on it. No, I mean, I could have just simply done this and got have done it this much, right? This is good enough, I feel. This is like 2 lines of code if you think about it. You know, somebody who is senior they will write this code. I'm pretty sure. Okay. This is exactly what you should have written. So that's what you should try to learn in these sessions. The best way to do it, or faster way to do it. I'll not say best because it might be that I don't get the best idea. Somebody else might have used it. Okay, so this is fairly good idea. Okay, let's read the next one. You are given two positive integers, x and y. In operation, you can do one of the following option: divide x by 11. Okay, if x is 11, divide x by 5, decrement x by 1, increment x by 1. What's the range of x and y? That's important. X and y can be anything. Okay. So what did you use for this? I have one doubt in this question. Why changing the question from A85 and A? BFS. This is BFS problem, correct. Okay. Try this with basic recursion memorization. Not sure what memorization. So see, recursion will work, but then it will so recursion will not work because there is loops in it, right? DP, recursion, these will not work because there are loops in this particular problem. So this is a very simple graph problem. Like ideally when you have these operations, right? I personally, when I see these problems with bunch of parameter, bunch of operations, the first thing that clicks in my mind is graph. What is happening to the configuration? Let's try to map it into some sort of graph, right? So I will always think about this. You are at x. I can from over here go to x by 5, given obviously this is divisible. I can go to x by 11. I can go to x minus 1. I can go to x plus 1. Now a very direct setup is, if I ever have to go to a number y, if y is bigger than x, then the only way is to kind of keep incrementing because these will decrease the value, right? Only when y is lesser, that is when I want to go to something smaller and then keep going forward. So the best way to decrease is what we have to find using these operations. And then when we start increasing, like at the end, we will always reach y in some possible way. So if y is bigger than x, then the only way is to keep increasing forward. If y is less than x, then we can just keep hopping forward and backward and see how much we can divide and like what we can do. So till like 10 to 2 into 10 power 4, you can set up a graph and do a BFS. Okay. With recursion and DP, it will fail. Why? Because there is a graph, there is a cycle in this code. Remember, recursion and DP only works on a transitions graph when you have no cycles in it. It's a DAG. DP, I have told this multiple times before also in my workshop also. DP is nothing but solving graph problems on DAG. Okay. So this is not a DAG because from x I can go to x plus 1, from x plus 1 I can go to x plus 2, dot 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 x plus 5, something like this, and then possibly I can go back also to x if like think about this as 1, 2, 3, 4, 5 and then 1. So there is cycle in this. Okay. I did it with recursion. Please code with BFS. So we can do this. We'll see how to write it with BFS. BFS is straightforward only, like set these operations and just use it. Ha. Right. I mean, yes, you can use it. I'll not say that it's wrong. Okay. Yeah. In this case, what is happening is like to decrement the greedy strategies will be very, very good. And on the increment side, there was nothing much powerful over here. If there was something like 2x and stuff like that, then you might start failing on using something like a DP. Okay. Yes, yes. This problem is possible to be solved with DP because x plus 1 is a very unique kind of operation, which means you can only go one step forward and there is only one way to increase forward. Okay. It is possible to solve it with DP. I'm not saying it's not. But then what you are doing is you are using some sort of cache or map. Okay. When you use map or things like that, you are basically just doing inferior kind of BFS. Okay. BFS does this only, or something like some caching, right? There is a value being saved. And if there is a better value, you replace it. That's sort of BFS. Okay. In fact, the exact algorithm that you are using, DFS, you are saving the like you are updating the distance in that. This is called SPFA. Okay. There is an algorithm called SPFA. If you are using this, but if you are writing DFS or just exploring recursion likh do, and then when you come to a value, save its value. If you get it with a better value, then update it. That's actually using this algorithm called SPFA. Okay. सर्च करो SPF algorithm. I'll not get into deeper into this. ये हम लोग use नहीं करते, ठीक है? But then you are actually using this. It works fast only in most of the inputs, but then it's not the best complexity. Best would be BFS. ठीक है? Yes, this is biweekly question 3. Correct. This is a BFS. This is actually a BFS problem, but it can be solved with like a standard recursion kind of thing. ठीक है? It's not faster. It's not faster, but good enough. ठीक है, explore it more. I'll not get into SPFA and stuff क्योंकि it's not a standard algorithm to know. Okay, but not natural recursions with updating its distance where the properties of Dijkstra is like where you are not maintaining proper visited states and stuff is basically SPFA. Okay. So this is a graph problem. We'll come to this. We'll come to these. I'll code the problems in a one go. Okay. But then एक idea लग गया कि this is a BFS problem. Is that part clear to all of you? We'll come back to the coding part as well. I'll code the things. Don't worry. Okay. If you think that this is a problem that needs coding, we will code it. But then first I want to go through so many. There are like 8 problems and there are a lot of ideas, right? Yes. If we don't have a weighted edges, then there is it's a BFS. Correct. That's a sure shot problem. Okay. So I think this is there. Let's move to the next one. You are given 3 numbers, start, finish, and limit. You are also given in 0 index string. String S, positive integer. a positive integer x is called powerful if it ends with s. Okay, and each digit in x is at most limit. Total number of powerful integers in the range this. So powerful range in this is this because it in this ends with this. Take it. Now, as soon as you see this problem, okay, what should come to your mind is there is a starting point and an ending point. L to R, you have to find numbers which follow certain property. Okay. From L to R, you have to find numbers which follow certain property. Okay. The limit is equal to 4, which means the limit is equal to 4, which means you have a bunch of like digit constraints and there is a suffix constraint. Okay. And they are fairly large. So this can only be one thing, which is digit DP. Okay. This is going to be nothing but a digit DP problem. Okay. How many of you know digit DP, by the way? I solved this, but don't know formally digit DP. ये कैसे हो गया? How does that happen, Chandrachud? ये मुझे समझाओ थोड़ा. Bit masking +1. Okay. I know, but I can't implement. Nightmare for even competitive programmers. I know, but I can't. Kyun? By digit DP, I think I'll have to make a video on this then. Digit. How many of you have seen my DP workshop, by the way? Okay. Okay. So in my DP workshop, I have not covered digit DP because it's an advanced form. But then in digit DP, it's nothing but it's a form 1 problem. So I'll teach you digit DP in very short. Okay. Ideally, it takes me so much time, but then I'll teach you something interesting. Week 14, yes. In the course, it will be in week 14. देख के सारे प्रीमियम के स्टूडेंट खुश हो गए होंगे, हाँ, क्योंकि सेम क्वेश्चन प्लेटफॉर्म पे करा रखा था. सो these like folks who are in AZ course, they know this question already, most probably. Sandeep, you have your code क्या link क्या? Like I think you would have coded this problem. It will be much easier for me to explain it with the code. तो वो भेज दो and I'll explain you guys digit DP in short. ठीक है, बहुत इंटरेस्टिंग बताऊंगा, देखो ध्यान से सुनना. ठीक है, listen to this very very carefully. डिजिट डीपी बेसिकली टॉक्स अबाउट L to R कितने सारे नंबर है जो कोई f of x सेटिस्फाई करते हैं. देयर इज अ फंक्शन which says that for a function it is true or not. When you put a number in this range, x belonging to this range in this, it will tell you whether it's a true or false. Count the number of numbers which satisfy certain criteria. ये function में in this question this is nothing but saying कि digits should be less than equal to limit and suffix should be some given s. ठीक है, this is the constraint in this problem. But then कुछ भी हो सकता है. This setup is something that digit DP solves. ठीक है, this is a setup that digit DP solves. Now digit DP is nothing but actually form 1 of DP. If you have not seen my workshop, please watch it. You will, I don't know, for most of you guys it might or might not seem that way, but I think it's one of the best ways to structure DP thought process. ठीक है, and I think those who have done can testify कि हाँ भाई कुछ तो फायदा हुआ है वो करके, right? तो एक बार go through that DP workshop, you will learn ton of new techniques, okay, and a better way to think about DP in whole as a whole topic. So form 1 basically says that first of all, everybody agrees that there will be, like, you are asked in this range, right? Let's suppose 1 to 6,000. So there can be 1 digit number, 2 digit number, 3 digit number, 4 digit number. I can find the number of digits. I can iterate on number of digits कि भाई कितने number of digits होंगे इस number में. I can find the solutions for 1-digit numbers, 2-digit numbers, 3-digit number, 4-digit numbers. Everybody agrees on this that I can individually solve these problems. कितने ही होंगे digits? Given the problem, you are given 15-digit numbers. So at most there will be 15, 16 digits. There will be at most 16 digits in the number, right? Finish जो भी R है. तो जो भी number तुम form करोगे, whatever number you form, there will be at most 16 digits over here. Right? This is something that will be true. Okay. Next. We are given that the last few digits is fixed, like whatever is S, like 124, this will be 124, right? I mean, I'm taking an example over here. There's like start, finish, limit, and S. Okay. So it's like these digits are fixed. They are 124 for this case, and then you can put some more numbers over here in the limit. Every digit should be less than equal to limit. That's the question. So digit DP basically says how to generate solutions to these things. Like there is like X digit over here. Last few things are restricted कि इस पे 1 ही होना पड़ेगा, इस पे 2 ही होना पड़ेगा, इस पे 4 ही होना पड़ेगा. There is like fixed digits that will be there. Over here you have choice between 1 to the limit that is given to you. In this case, what is the limit? Let's see. Limit is 4. So in this case, the first position can have numbers in the range 1 to 4. The second position can have numbers in the range 1 to 4. Every position have that choice. Last few digits has only these choices. What the question is asking is, find the number of solutions on how many ways can you choose things from the allotted possibilities such that this whole thing lies in the range L to R. Okay? These are the choices for every digit over here till this much. This is, let's suppose, S length of S. This is X minus length of S. Yeah, sorry, this is 0 to 4. My mistake. Yes, correct. Right? Except the first one, everything can be 0 to 4. Okay. So this is something we can think about. And then digit DP basically gives you a way to think about how do you generate numbers in possibly ranges of this particular way. Okay. This is exactly what digit DP does. And now I was saying that we will have to think about how do we make the last, like this as 1 digit, 2 digit, 3 digit numbers. Maybe if I apply this, allow this to be 0 also, then I can generate any digit number. मतलब अगर ये सारे 0 है, so this will be a 3-digit number. If this is like 1 or some non-zero, then this will be 4-digit number. If this is 3, this is 2, then this is a 5-digit number. But then all numbers will be generated if you have full possibility over here, and this last few digits has to be 124. Okay, just that it has to be in the range L to R or start to finish. And then these are the possibilities for the first few digits. This is the possibility for the last few digits. Is this making sense to all of you? कि हमें नंबर कुछ मैक्सिमम एक 16 डिजिट तो नहीं, R का जितना नंबर ऑफ डिजिट है उतना ही करना पड़ेगा. वर्स्ट केस इज दैट्स द केस. बट देन इफ यू थिंक अबाउट इट, 16 डिजिट को सोचेंगे कोई प्रॉब्लम नहीं है. इफ यू हैव 16 पोजीशंस, ठीक है, R is given to be 6000. So I'm just drawing some cases over here. There is, let's say, 7 positions. ठीक है, R is 6000. Smaller number is, I'm just taking a random number, 23. I'm just taking start as 23, random. Okay, just it can be possible input, right? So what I will do is I will prepend zeros in this, and I will prepend 0 in this, and I will say I have to choose numbers in these positions such that it lies less than this and bigger than this particular number. That's what we have to do, right? Each of these positions has a set of choices. Okay. These last few choices is dictated by the string कि भाई इस पे 1 ही डालना पड़ेगा, इस पे 2 ही डालना पड़ेगा, 4 ही डालना पड़ेगा. But you have to choose what do you put in these positions such that the number that is formed is less than this number, less than equal to this number, and is greater than equal to this number. Is that the problem that we are solving? Yes or no? These have choices 0 to 4. This have choices 0 to 4. This has choices 0 to 4, and so on. Is this the problem? right? And then when you have things like this, you use standard digit DP. What is digit DP? Digit DP says that, okay, I will go things in a positional order. So that's form 1, DP of I. I am deciding this particular position T low, which is tight low. Basically says ki whatever I have placed till now, am I still equal to the lowest digits in the first few digits? Yes, I am equal. So T low will be 1. T high, am I equal to the highest digits as of now? T high. Okay. This is what we keep in digit DP. Okay. And we just follow this to solve the problem. This is what generally the states mean. This is the index I am currently deciding. This is, am I equal to the lower side? Am I equal to the higher side? That's what T low, T high means in digit DP. How will this work? We start with, I'll just remove this. I'll show you a very interesting like simulation and that will make it all clear. Okay. So let's suppose we are starting. Abhi hame is pe decide karna hai. What do we put over here? So I can start with DP of, I am starting at index 0. I am like before this there are bunch of zeros only. There are bunch of zeros only. There are bunch of zeros only. So I am still equal to low and high, L and R. Okay. So I am equal to 0. So this is going to be 1. I am equal to this. So I am 1. Okay. From this, if I'm equal as of now, I can only put things in between these two digits. 0, 0 के बीच में डाल सकते हैं. So I will have to place a 0 over here and move forward. So I will go to DP of 1, अब मैं index 1 पे हूँ. I am still equal to low and high. I have to put a 0 over here. I'm still equal to this. So DP of 2, 1, 1. I have to still put a 0 over here. DP of 3, 1, 1. Okay. So I'm basically trying to put whatever digit I can put over here and then see where will I reach, in which DP transition I will reach, which index I will reach. I have to put 3 onwards, and since both low and high were having 0 digits over here, I had to forcefully put 0 over here. क्योंकि 0 0 के बीच में तो 0 ही आता है ना. The number has to be between the two numbers. अभी तक सब same है तो leading digit same होना पड़ेगा. That's the constraint. Now this is where things become interesting. ध्यान से देखो. हाँ करते करते अभी तक टी लो टी लाई आया ही नहीं ना, यूज ही नहीं हुआ है. सो लेट्स सपोज वी आर पुटिंग डीपी ऑफ, अभी हम लोग इंडेक्स 3 पे है. अभी तक दोनों टी लो टी हाई 1 है, मतलब जो भी प्लेस करा है वो लो के बराबर है, हाई के बराबर है. दे आर इक्वल इन टर्म्स ऑफ व्हाट इज बीइंग प्लेस्ड एज ऑफ नाउ. इधर भी 0 0 0 0 0 0 तो टी लो वाला 1 है, 0 0 0 0 0 0 तो टी हाई वाला 1 है. ठीक है. नाउ व्हाट हैपेंस, व्हाट कैन आई प्लेस ओवर हियर? What are my options? Tell me in the chat real quick. What are my options? 0 to 6? Not really. There is one more constraint, no? That limit is there. Limit is up till 4. Limit is equal to 4. So I can place digits from 0 to 4. Okay. This is where things will start diverging. Acha, what if I place a 0? What if I place a 1? What if I place a 2? What if I place a 3? What if I place a 4? This is where DP's transitions comes into action. कि भाई यहाँ पर क्या रखेंगे? I have my choices. उसके हिसाब से I will go to new states. ठीक है. Suppose I place 0. Which state I will go to? I will go to the next position. DP of 4. I have to fill 4 and onwards. If I place 0, I am still equal to the lower side. 0 के बराबर है ना? 0 0 0 0 0 0 0 0. So T low is 1. Am I equal to the higher side now? Yes or no? No, right? So I will put 0 over here. ठीक है. When I have to put a 1, I will go to DP of 4. I have put a 1 over here. ठीक है. Am I equal to the lower side? No. So this is 0. Am I equal to the higher side? No, this is 0. In fact, all of these will be DP of 4, 0, 0. And you can see this is where DP will come into action. Once when you will go over here and you will calculate this, you will cache this value and they will directly be returned by these DPs. These all will lead to the same thing. ठीक है. कि भाई 4 के बाद कितने वेज है भरने के, ये बता दो मुझे. You will see that DP of 4 0 0, you will go over here. यहाँ तो एक ही way है, यहाँ पर एक ही way है, यहाँ पर एक ही way है. So you will have to forcefully put 1 2 4, okay, and you will get the solutions that are required. कि भाई इधर एक ही way है, 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 because they are forced, right? I'll take one more digit. Yeah, it will make more sense. That's not fixed. Correct. I'll take one more example. ठीक है? And then it will be fully clear. इस पे क्या है? When I put a 0 over here, I will go to the next and then I'll have to still put like bunch of numbers. When I put a 0, this means I am still, once this t high becomes 0, देखो t high जब 0 बन गया, so I am no longer restricted by 0, क्योंकि मैंने 6 के नीचे 0 बैठा दिया है, तो ये नंबर ऑलरेडी छोटा हो चुका है 6000 से, so I can put anything over here. That's the main idea of digit DP. कि भाई अगर जब तक पूरा बराबर है तब तक तुमको हाई वाले डिजिट से कम बैठाना पड़ेगा. फॉर एन एग्जांपल, लेट्स टेक अ वेरी इंटरेस्टिंग केस. ठीक है, 3 4 2 1 एंड देन 0 और 3 1 3 5. ठीक है, I have to generate numbers between these two. How will it work? Let's suppose these are the 4 positions and I have to fill 4 positions over here which such a digits such that it is in this range. Okay, for the first, what is my options? Option क्या है? Because I am at 0 with the t low and t high as 1. जब तक t low t high 1 रहता है तो क्या होता है कि आपको इसके बीच में नंबर्स डालने पड़ते हैं. अगर t low 1 है so you have to be more than 3. If t high is 1 you have to be less than 3. So you have to put exactly 3 over here. Okay, and if you put 3 over here you will go to the next thing. Am I still equal to my higher prefix? Yes. DP of 1, my t low is still equal to the whatever was there in the low number. So yes, 1. Am I still equal to high number? Yes, 1. Okay. Now let's see. Now what will happen is I can put, since I am still equal to both of them, I have to be more than 1 and less than 4. नहीं तो फिर ये number इस range से बाहर चला जाएगा. This is the main idea. How is it generating numbers only in this range? I can put a number over here such that it is less than this and greater than equal to this. Okay. So I can put 1, I can put 2, I can put 3, I can put 4. This is the main idea of digit DP. Now, if I put, let's suppose 1, in that case, I will go to DP of, I have to fill then this much to 1 put क्या है तो low के बराबर है अभी भी. So if I put a 1 over here, I am still only 3. Why not 4? Forget about the original problem. अभी हम लोग वो F condition check नहीं कर रहे, बस numbers generate कर रहे हैं सारे possible में भी. Only 3 0 1 2. अच्छा, sorry. Okay, that was previous message. Okay. 2, I will go to 2, index 2, and I will have taken 1 over here. So it's still equal to the low side. So it is still equal, and then on higher side it's no longer equal. So now since I'm no longer equal to my higher side, see, I can put on the higher side, on the lower side I have to be greater than equal to 3. I have to be greater than equal to 3. But then on higher side I can be less than equal to 9 because 4 से यहीं पर छोटा हो चुका है नंबर. So यहाँ पर तुम 9 भी डाल दो तो ये नंबर ऊपर वाले से छोटा होने वाला है. That's the beauty of it. If you maintain that, if you are still equal, then you are restricted by the numbers that are present in that particular digit. अगर तुम अभी पहले छोटे हो चुके हो या बड़े हो चुके हो, depending on higher limit or lower limit, you are now free to choose what digit to place over here. And that, my friends, is the main idea of digit DP. यही करता है digit DP कि वो आपको restrict कर देता है कि what are my options to be placed in this particular digit based on what I have done previously, ताकि ये इस range low से R के बीच में रहे नंबर. ठीक है, दिस इज द मेन आइडिया ऑफ डिजिट डीपी कि आई एम मेंटेनिंग अ टी लो टी हाई व्हिच सेज कि भाई अभी तक मैं बराबर हूं कि नहीं. अगर बराबर हूं तो आई एम रेस्ट्रिक्टेड विद द लो एंड हाई ऑफ द नंबर्स दैट आर प्रेजेंट. बट देन इफ आई एम नॉट इक्वल, सी इन दिस केस आई एम ऑन द हाई साइड, आई एम नॉट इक्वल, सो आई कैन टेक 9, आई कैन टेक 8, आई कैन टेक 7 आल्सो. बट सिंस आई एम रेस्ट्रिक्टेड बाय द लोअर साइड, आई एम स्टिल इक्वल, तो आई कैन नॉट टेक 2 ओवर हियर. नहीं तो ये नंबर तो इससे छोटा हो जाएगा, राइट? इफ आई पुट अ 2 ओवर हियर इट्स स्टिल लेस देन दिस, सो आई विल गो टिल 3. So digit DP just allows you to maintain what are my feasible choices in each digit. That's all. That's exactly the idea of digit DP. ठीक है, अब हम एक कोड देखेंगे, उसमें I will explain the rest of the things. I think Sandeep has implemented it in the way I teach it in classes. So exact same idea I'll explain. This will be much better. Okay. Okay, तुमने इसको pass कर दिया है. You could have saved it in a separate variable. I think that would have been better. So basically what he has done is he basically first converts this into equal length strings. Okay, I'll explain this code in short. 6,000 is a number. So you are adding the start state in the same DFS and DFS, it's a DP. Okay, but yes. Yeah, you can do that also. You can do that also. Key end minus start minus one, you can do that. But then generally we in digit DP, I generally teach it in this way that you put T low and Ti. So you have done it in the same kya? Nahi, T low, Ti is separate. Okay. I teach it in this way. You keep two separate states if required. Okay. In many problems you can do this way, but then sometimes you cannot do it that way, Sarthak. Okay. Yes. This is exactly how I code. I mean, Sandeep is his course, so he knows. I have taught him, so I know him. That's why I'm taking his code, because this is my style and I'll be able to explain this also. Chalo, let's see. What is this code? You take the numbers 1 and 6,000, but they are integers, long numbers. So you have to convert it to string and build this part. I have shown na कि यहाँ पर जैसे था कि 1 and 6,000 आया. So we had to build this string कि भाई 6 0 0 0 and then 0 0 0 1. These two numbers that are there, this is being created in the code over here. Okay, maybe I'm not sure, but it might be possible. I'm not sure 100%. So this is what is being created. Ki wo numbers create kiya, then 1 has lower number of digits, so there has to be a lot of zeros being added at the start, right? So that's what he's doing, and then he's just doing a memset on DP array to be -1 and then calling the digit DP. Okay. Sandeep, one small pointer: string copying in vectors is like very costly. Like it's copying it multiple times, so your actual complexity is like 15 into 15 over here. Matlab, these are getting multiplied. Since the number had 15 digits only, like it worked, but then ideally pass it by reference. Okay. In some bigger problem where you have bigger strings as limits, you will get TLE. Okay. Yes, this should be passed by reference. Or ideally in Leetcode, what I do is I just keep those variables in a separate name over here and use it, because they are constants. No, you're not changing that anywhere. Okay. So what we have done, if id is equal to n, this is like base case. So I'll just snip this off. I will move it over here. I'll move it over here. Chalo. Now we'll have bunch of things available together. You know, this is the best way. So you go to this I is equal to n. This is like base case कि भाई ये 0 index था. This is 0 index, 1 index, 2 index, 3 index, 4 index. This is the base case. Exactly how I have taught Form 1 in DP workshop. Please watch that on YouTube. There is no better investment on DP than that workshop. I can guarantee you that. If you know the basics, I mean, you should know what DP means before you watch that workshop, I feel. But then it will actually build you the edge that is required to get good ranks in competitions and Leetcode and stuff. Okay. So watch that. I mean, Leetcode questions, even hard questions will become very easy for you after that. Most of it, if you complete it properly. By the way, if you want to complete that, I'll just quickly link this. I mean, you can go to this mang.in, right? And over here in the courses section, it's like there is the DP workshop is properly available in a structured course now. Like so this happened way back on YouTube. All of this is now available in a structured way on this site. Okay, so you can watch the live sessions of that day, solve the problems of that day. Okay, and then there was a doubt session back then that I took live. This is like 1 year ago. But it was a really good session. Really good workshop that happened. So you can solve these from this site directly. Okay, check it out. Has anybody solved it as of now? Oh, people have started doing it on this site. It was added some day before only. Nice. Okay. Let's come back. So what is happening over here? There's so many alarms. This is for me to wake up most probably. Okay. So this is the base case. Then if you have the value saved, then return it from the DP array, or else this is my possibilities that I can go from digit 0 to digit 9. Okay. Then if I'm still equal to my lower side, then I can only do better than lower. My lower end is same as the lower string digit there. If the tight is 1, if the lower tight is 1, if the lower tight is 1, then I can only do better than 3. So I am finding the strings this digit, minus 0 will be the number, and I can do better than number only over here. That's the thing. Okay. Then on the higher end also, if I'm still equal to my higher number, then I can at most go till this. Then I will go through all the numbers. I think you could have done a little better, that the higher limit by default is the limit only, right? So that would have done this part easily resolved. I mean, more loops, but then anyways, it's getting handled. So this is how you write, like after you place this digit, is it still equal to the lower or higher? You create new T low or new T high, T tight, or and new high tight. You create those things. Like if it was already equal and this is also equal, then it is equal. Basically, that's the logic. So if this is not equal to the lower side, then it is not equal. But then if it is equal, then if already it was equal, then only it will be equal. That's the idea of calculating this new T low. So it's, if all the way it has been equal, then this can possibly be equal, given that this digit doesn't mismatch. That's the idea of calculating T low. This is T high. So this is where you will go, the new DP state. And then if you are inside the limit, you will check if you are in the last few digits or not. If you are in the last few digits, then you are forced by the digit that you take over there. Okay, that you have to forcefully take this number, the suffix that is given to you. So the force option is over here. This is how he has implemented in his code. You could have checked that over here also, that you make the range equal to exactly one digit. So new T low, new T high is basically, acha, yahan par T low, T high was 1, no? All, both of them was 1, T low, T high. So over here we went to, this is new T low, this is new T high. How are we calculating? कि भाई यहाँ पर अगर 1 बैठाया, if you put a 1 over here, it was already equal in the low side, and this digit is also equal. So this will be 1. On the higher side, it was equal, but then this was 4 and you put a 1. So this is no longer equal. So this will become 0. That is what we are kind of calculating over here in the code. If it is equal, then this is there. So that is how you're calculating need to. And then if at the end, final few digits, if you put a particular character which is equal to the, like you will have to forcefully put it. Then if it is possible, if that is what you are putting, then it is feasible, nahi to ignore it. Or else if you are not in the last few digits, then you are free to choose whichever number you were looping through right now and just save the answer over here. I think Sanandeep को ये करके मजा आ गया होगा इन कॉन्टेस्ट, क्योंकि ये एग्जैक्ट टाइप का आइडिया तो हमने देख ही रखा है. पैलिंड्रोम क्या क्या कर लिया था, तो ये सेम क्वेश्चन तो तुम्हें लाइक कॉन्टेस्ट में करके मजा ही आ गया होगा. राइट. ठीक है, ठीक है. So this is exactly the same implementation of the thing that I discussed. ठीक है. Practice digit DP. I obviously, like this is a Leetcode discussion, I cannot 10 मिनट में कोड हो गया था, क्योंकि आइडिया अगर पता है तो डायरेक्ट हो जाएगा. How are we accounting for suffix? For the last few digits, I am only allowing the j to be put and go into recursion if j is equal to the strings digit that is given to us, the suffix wala thing. I'm only allowing those digits. Right? That is how this is being held accounted. नहीं तो फिर उधर जा ही नहीं रहा है, and the default value of the p is 0. The answer is 0. So it is getting saved 0. That you will not get any number there if it's not feasible to put. Okay, let's see चंद्रचूड़ का क्या किया है अर्जुन ने. अब क्या है ये? Okay, I think what you have done is you subtracted the 2. मतलब I think what you have done is similar to this, but पता नहीं. Is this इतना अच्छा कोड लिखोगे? Is this your own code या फिर is this leaderboard code? Nice, काफी प्यारा कोड लिखो. But then इतना अच्छा कोड मैं लिखता नहीं हूँ जनरली. Okay, did it after contest. I highly doubt can somebody write like proper camel cased codes in competition, but anyways, ठीक है. इतना अच्छा वेरिएबल नेमिंग आज तक नहीं करा है. I don't think that's the best idea. Never try to do these things. Okay? If there's a strategy that works for everything, use that instead of trying to incorporate something that works only on this problem. Every digit restrictions I can handle very easily. So handle it there instead of handling it in the base case. I generally don't do that because the numbers are in the range L to R for the last few digits also needs to be handled. So I don't want to handle that in my base case. Okay. Chalo, cool. This is good. Good code. Nice. Chalo. So we have discussed, I think, all the problems of this particular contest. We will next move to the Leetcode weekly. Which one is this? 7379. Nice. I have a doubt regarding third question. The moment you mentioned BFS, I solved it in 5 minutes during the meet only. But how to actually know BFS is the right approach here? So you should have seen the similar problem before. I have sometimes people ask me that, Vivek, how do you solve such things? How do you know that this is the approach for this? 80% of the time I know I have seen similar problem before. 80% of the time that's the case. Okay, that's how I know that this is what is to be used. The next thing is there a cycle in this graph or not? When so there are so I don't know if you have seen my blog on code forces or not, but then you have something called as frameworks and forms. Okay, in DP I've taught forms and frameworks only in the whole workshop. So you need to know what should you ask when you see a problem. When I see a operations problem and a configuration x to y, I have to change a configuration from x to y with operations. It's always graph as my first thought. That's my framework. Because people tell me कि विवेक मैं सोचूंगा इसको करूंगा कुछ कुछ करके, ठीक है? What do you think when you see a problem? There has to be a logical way that you will go forward, right? Yeah, random सोचोगे कुछ intuition आ जाए मुझे, something randomly comes up to my mind and I will be able to solve it. That's not how it happens. ठीक है? So there is a initial configuration, final configuration, and there is a set of operations. It's mostly graph that you think. Maybe if things become DAG, then maybe we'll go to DP and all those optimizations we can think about. But then there has to be a frame of thought at the start itself, and that's how it should come. Yes, BFS guarantees shortest path. Correct. Shortest path is what you look at. How to create the graph? वही है, x से x minus 1, x plus 1, x ये सब connect करके and then run BFS. And go till x plus 11 only in terms of creating the nodes. Right. Okay. Chalo, let's look at these problems real quick. Should be straightforward in the initial side. You are given a 2D zero indexed integers array dimension. This okay. Okay, max into max करना है क्या? I don't know. Area of the rectangle having the longest diagonal. Okay. सब iterate करना है सब पे. हाँ, Q handles the BFS. Yes. Basically, so Nimit, I'll show the code. Yeah, thanks for sharing this. Basically, you don't. So this is something called as implicit graph. I don't know if you have read about this or not. So there are two types of graph. One is explicit and implicit. Explicit means you create that adjacency list. Implicit means there is a rule and based on that you just transition directly. Okay, so this is an implicit graph and you just put them in DFS. That's it. Okay, should be pretty much it. Yes. Put this in queue. That's it. Chalo. We'll go back. The first thing I see is there a cycle in that one. Okay. Next is maximum area of the longest diagonal. So this is, I think, direct iteration. Anybody has any doubt in this? This is like simply loop over all the, like each of these and this and whatever is the diagonal, and diagonal ka square you can maintain and compare that, because if diagonal is bigger then diagonal square is bigger, so that will be an integer. You can compare that, and if that is bigger then you update it with the area, maintain that. It's very straightforward implementation, brute force code. But the thing that I mentioned is very important. Maintain, like comparing diagonal square is better than comparing diagonals. Okay, I mean, in this question I think the dimensions are small, so you will not face a problem, but when you do square root and stuff, you will get issue in bigger constraints or floating point numbers and stuff, right? We don't want to go to that kind of a place where a square plus b square, there are two different squares that add up to the same thing. Okay. Correct. Minimum number of moves to capture the queen. In this, there are 6 integers A, B, C, D. White rook, white bishop, black queen. Nice, nice, nice. I think I can always do it in 2 moves, and I have to just check, can I do it in 1 move or not? Is that the idea? I'm just thinking. Because this is exactly how you think. Okay. So basically, see, since there is a rook on the board and there is a queen I have to capture with the rook to the queen, the main idea was he rook has 2 axes. I can go up and capture, I can go on this side and capture. So wherever the queen is, the bishop can interrupt on only one diagonal, on only one side. Okay, I can always take the other route. So there are 2 disjoint routes which can attack the queen, and the bishop can be on one of them. So I can always do it in 2 moves, right? The thing is, I might be able to do it in 1 move, and that's what I have to check. So you'll have to write the code for check. By bishop diagonal, keep iterating on both all the 4 sides unless you see a rook or a queen. If you see a queen, you can do it in 1. If you see a rook, you stop on that diagonal. That is, I think, more difficult, like the hard edge case that you had to implement. By diagonal pe ja rahe, and there is bishop, rook, and then queen. So the bishop's attack is getting blocked by rook, right? And how would I have implemented it? I would have just simply thought about go in each direction and keep checking what is the first thing that you hit. Okay. So you have a direction vector and you can just go in that direction. Ki bhai, jate ho, jate ho, jate ho, and see this. Okay. Implementation. I think if you found this hard, this was mostly implementation issue. Everybody agrees? अगर कुछ hard है तो implementation थोड़ा mistake हुआ होगा कुछ edge case. There is nothing hard in the logic for sure. Right? Good. Nice. Let's see the next one then. If you will ask me, I'll implement it, but then I don't think there is any value in that compared to looking at harder problems. So let's see that and then we'll come back if required. Okay. Maximum size of a set after removal. You are given 2 zero index set arrays m1 m2 of n. You must remove n by 2 elements from number and number 2 elements. So after removal, you insert the remaining elements of number into set S. Okay. So I have to take most number of distinct element. Is that what is being asked? Okay. Possible to do it after contest. This is interesting because I think there are multiple solutions that will be wrong. Okay. So I'm thinking that, okay, I can try thinking about taking elements greedily from one of them and the other of them. But then what is happening is there is possibility of mistakes that might happen. Ki, acha, if I try to take too many from one of them greedily, What will happen in the other one? I might be stuck with bunch of numbers being repeated multiple number of times, right? So obviously I can compress each set into a number and its frequency and think about it in terms of that, right? So what my mind is right now saying is basically there is like bunch of elements which frequencies, like X has frequency, A has frequency X, B has frequency Y, C has frequency Z, and similarly there are a bunch of elements over here जिसका frequency दे रखा है, and we have to take half of the elements from over here and half of the elements from over here, right? Okay, so how do you then in that case make it optimal such that most number of elements get distinct? So there are three kinds of elements if you think about it. Okay, my thought process would be there are three kinds of elements: only in A, only in B, both in AB. Does this make sense to all of you? There are a bunch of elements which are only in A, only in B, both in AB, right? And obviously, like if a element is there twice, there is no point in keeping it twice. मतलब अगर दो बार है तो अब क्या करें, उससे कोई फायदा तो नहीं है, right? So I'll just make it a set in A and B only, and then I have to take n by 2 from one and n by 2 from other. If there is not sufficient element, then I will ignore that. मतलब I'll think that some duplicate was taken basically. Okay, so for an example, I'll just explain what I'm thinking. If I'm given things like this, or this is a better, this is example. This example is better. If I've given something like this, I will convert this into a set 1, 2, 3, 4 up till 6, and this one has just 2 and 3, and I have to take 3 elements from over here, 3 elements from over here. Okay, that's what I'm thinking about. And if there is like not sufficient amount of elements, then which means I'm taking something duplicate, so it will anyways not help me get more number of duplicate new elements. Okay, so there are these two things. Everything is available either once in A, once in B, or once in both of them now. So the problematic things are these only, I feel, which are available in both of them, right? So when it's available in both of them, so let's see. Let's suppose there is X such elements, there is Y such elements, and there is Z such element. Okay. And I have to take total n by 2 from A, total n by 2 from B. So what would I do is, whichever one is more restrictive, I will try to take lesser from that, and whichever one has more element, like, so say, since there are 2 elements and you require 3 elements, it's better to take it from that, right? So I'll first look at elements which are available in both. No, I'll first look at elements which are available only in one of the elements, one of the sets. Okay. So I have to get 3 different elements from over here, right? See, there are certain elements which are available in both. If I can fulfill all of these 3 with only A kind of elements, because they will now be included in the set, then I will be able to take the elements that are there in both A and B and only in B, both in this limit. So I will have more choices left for later on, right? In such case, in this input, what you can see is that there are 6 elements in only A, 0 elements in only B, and 2 elements in both. So what I will try to see is, can I fulfill the requirement from A with just only A and B with only B? So there is a requirement of 3 and there is a requirement of 3 over here. Okay? So with just A, I can fulfill 3 of them. So 3 यहाँ पर add हो जाएगा, and I'll be left with 3 elements in A only, which I cannot take. I cannot take any more elements from 3. I have 2 elements in B. I will try to take 2 elements from B. 0 elements only in B, but they are not there. Then I will try to take the elements which are there in both. Okay. So I have to ensure that I have not taken it in either of the previous things, which will be ensured because I was taking only element which is available only in A and B. Sorry, this is 4. Okay. Number of elements only in 4, 1, 4, 5, 6. 4 such elements exist in only A. 0 elements exist in only B, and 2 elements exist in both. Requirement for A is 3, requirement for B is 3. First, try to fulfill these requirements with only their own type, because they will always be distinct and I will be left with elements that can be taken in either of them to balance them out later on to get more distinct element, obviously. So 3, I have 4 elements over here, so I can fulfill this 3 with these 4 distinct elements. So I will get how many? 3 elements. All 3 will be matched. For this, I will get 0 elements. Okay. So I will be left with demand of 0 from A and demand of 3 from B. Now I will see the elements that are available in both. The total demand left is nothing but 0 plus 3, 3. I can fulfill with 2 of the boths. So I will fulfill that. So I will be able to take 2 of the elements and 1 cannot be fulfilled. So the answer will be 5, right? I mean, I tried taking 3 over here and I was able to take 2, but this 1 I could not take anyways distinct. So the answer is 5. So first, greedily try to take from only A and only B to fulfill the needs of A and B. If that is done, that's good. If not, then try to take it from both of them, because both wala thing can help us later on manage the demand in either of them. Jisme bhi bach jayega, I will try to put things in that. So first, try to take only A and only B. That's how you think about greedy problems. This is exactly how my thought process would have been. Think about what kind of elements exist and how to think about it. That's what you do. Okay. Okay. That's it. बस ये करना था और कुछ नहीं करना. Okay. Let's see the last problem. भाई ये क्या है इतना बड़ा सा. अच्छा एग्जाम्पल पढ़ा है तो स्टेटमेंट छोटा है. समझ में आया इसका आइडिया? इज दिस आइडिया क्लियर टू एवरीवन? yes, इतना क्लियर थॉट प्रोसेस होना पड़ेगा. That is how you solve, like how do you think people are like senior competitive coders are able to think about problems and solve code forces CED problems faster? It's not about कि उनको ज्यादा आता है, it's not always about that. It's more about कि they have clear deduction process. ठीक है, मैं क्या सोचूंगा मेरे दिमाग में वो क्लैरिटी रहता है. I have with practice built a framework कि मैं क्या सोचूंगा and I'm able to do that very fast. That's what make people better in coding over time. ठीक है, नंबर ऑफ टेक्निक्स तो सीख ही जाओगे. मतलब once first time you come across something that you don't know, आज DGDP देखा तो सीख ही गए थोड़ा बहुत कुछ. अब क्वेश्चन करोगे 2-3 तो हो जाएगा. It's possible to do that way. But then the harder bit is to look at, can you think in a logic, can you build a framework for yourself? Sherlock codes. Nice. Science of deduction. ठीक है, चलो let's look at the last problem. If we are able to solve this, then we are good to go. You are given 0 index string s and an integer k. You have to perform the following partition operation until s is empty. Longest prefix of this containing at most k distinct element. Choose the longest prefix, at most k distinct. Longest prefix, okay. Delete the prefix from s and increase the number of partition by 1. Okay, from the again we'll do partition. Before the operation, you are allowed to change at most 1 index in s to another lowercase character. Okay. Return the integer among the maximum possible after choosing optimally at most 1 index. Nice. How many of you were able to solve this? This is a good DP problem. You can think about this DP already. Chalo. This is a very good problem. Okay. There's like 3 tricks, 3 things involved in this one problem. Okay. One is which DP form will it be part of, how to manage that one change, and then the third is how to optimize the transitions. ठीक है, ये 3 चीजें इसमें इन्वॉल्व है. समझ रहे हो? मतलब मुझे इस प्रॉब्लम को देख के क्या दिख रहा है? मुझे इसके 3 लेयर ऑफ डिडक्शन दिख जा रहे हैं कि पहले ये देखना है, ये देखना है, ये देखना है. ठीक है. First things first, I'll teach you how to think about such hard problems. देखो, हाउ इज इट काइंड ऑफ अनरावलिंग इन माई माइंड, कैसे करके काम कर रहा है दिमाग, ये चीज समझो. आई अंडरस्टैंड दिस इज हार्ड टू सॉल्व ऑन योर ओन एज ऑफ नाउ, ठीक है, ये तुम लोग को खुद के सोचना पड़ेगा, थोड़ा डिफिकल्ट है, बट सोचो पॉसिबल कैसे है, ये सोचो, ये सीखो ध्यान से, ठीक है, बहुत इंटरेस्टिंग है. आई विल पिक दिस अप एंड मूव टू द अदर साइड बिकॉज बार बार इधर ट्रांजिशन करने में को बहुत टाइम लग जाएगा. And then I'll paste it over here. पेस्ट हो जा भाई, हाँ पेस्ट हुआ ना. Let's see. Nice. So there is a string, ठीक है. What will happen is you will choose the longest prefix of x containing at most k characters, k distinct characters, ठीक है. एक तो यहाँ पर at most longest prefix at most k distinct characters, ठीक है. Delete that and then again do it. So first things first. Since there is some change and you have to delete and see how many things are available, ठीक है. There is a term in this which is the key of this whole problem, ठीक है, which is called you have to partition. कितने लोगों को दिख रहा है पार्टीशन वर्ड, दिख रहा है नहीं दिख रहा है? Okay. So whenever you see the partition word, right, तुम्हें सोचना पड़ेगा कि this is a form 1 या form 2 problem of DP. Generally when you have to partition in such a cut कुछ cut वट करना है, कुछ optimality maintain करते हुए कुछ is generally form 1 form 2 DP problem. Why is that? Because think about this, when you see such problems, right, when you make the first cut done कि ये एक set हो गया, it's a recursive problem कि भाई ये suffix के लिए वापस problem solve करो, right, you have to again solve the same problem for the suffix. Okay, so immediately DP comes into action. Next is how do you think about it? You think about कि भाई DP of I, that from I till n everything is left, what is the optimal way to cut it, or what will be the solution for what will be the number of moves required for it, and you can maintain something, some sort of extra parameter that will help you design this part after choosing the optimal condition. ठीक है, ये change अभी तक हुआ है कि नहीं, I can maintain that. So I will have to choose one of the index and change it. ठीक है, तो देखो longest prefix s containing at most k characters, if nothing changes, is this fixed, yes or no? अगर सपोज कुछ चेंज नहीं करना होता, क्या मेरा आंसर फिक्स्ड है? Longest prefix of s containing at most k characters. So from over here whatever is the longest, ठीक है, जहां पर पहली बार k characters तक k distinct characters तक ले सकते हैं वहां ले लेंगे. अगर if I taking the next one I am getting k plus 1 distinct characters, so I will not be able to take it, and there will be a fixed point till which I can delete the whole thing. It's fixed, right? And then again for the rest of the string it's again fixed कि भाई यहां से भी कोई fixed position होगा जहां तक तुम ले पाओगे, and so on. For an example, if you see this input over here, if I don't change anything, A C C C A, two distinct at most, okay, k equal to 2 distinct. So if you don't change anything, यहां से लेंगे 2 distinct, पूरा सब कुछ खा लेगा ये. Is it not the case? Suppose यहां पर एक B होता, तो ये यहां से यहां तक खाता फर्स्ट वाला पार्टीशन, एंड सेकंड वाला would have been something like this. But then we can change it, मतलब obviously we'll get into that, okay, but we can change it. So everything was fixed, but what made the problem? This one change, okay, one change is what kind of made all the problem. So what will we look at in this case is we have to decide at which position we will make the change, okay. So we can think about, have we made the change as of now, yes or no? That is what we will look at कि भाई चेंज हमने करा है कि नहीं करा है अभी तक. That's what we will maintain in the DP state, क्योंकि चेंज कर दिया तो I can change it to any character as how, like whatever I wish for. And if you think about it, देखो यहाँ पर A C C C A था, ठीक है, You have to make the maximum number of partition. So if I change something, I will try to bring it to a new kind of character. Like isko B banana is optimal, so that this becomes one, this becomes second partition, this becomes the third partition. Is it not? Like I'll try to maximize the number of partitions. So I will try to change something to into some new character which is there uh, at the farthest position. Okay. So what we will look at is we'll try to change something as into something new. मतलब अगर हो सके तो possibly. ठीक है. अच्छा, okay. See, यहाँ पर A है, C है, D है, A, C, C, D, E, F. ठीक है, ऐसा कुछ. अच्छा, यहां से मेरे को एक डिस्टिंक्ट कैरेक्टर यहां तक मिलेगा, दो डिस्टिंक्ट कैरेक्टर यहां तक मिलेगा, 3 डिस्टिंक्ट कैरेक्टर यहां तक मिलेगा, 4 डिस्टिंक्ट कैरेक्टर यहां तक मिलेगा, 5 डिस्टिंक्ट कैरेक्टर यहां तक मिलेगा. Can I find these positions real quick? Yes or no? Can you guys find this? कि मुझे फर्स्ट डिस्टिंक्ट कैरेक्टर कहां पर मिलेगा, सेकंड डिस्टिंक्ट कैरेक्टर कहां पर मिलेगा, थर्ड डिस्टिंक्ट कैरेक्टर कहां पर मिलेगा, एंड सो ऑन. Can I find this fast? How many of you know how to find this fast? This is the next trick involved in this problem. From any particular starting position, if I want to find quickly, where will I find 1 distinct, 2 distinct, 3 distinct, 4 distinct, 5 distinct, and so on? Can you guys do this fast? O of n, so everybody can do, I think, faster than that. Prefix sums, not really. 2 pointers, not really. Okay. Basically, what you do is you maintain the positions of each character. A is present at 0, C is present at 1 and 2, D is present at like 3. Yeah, map of positions, correct. E is present at 4, F is present at 5 and 6. ठीक है. Suppose मैंने तुमको पूछा कि भाई C से बताओ, index 1. So what you will do is lower bound with 1. A तो present ही नहीं है 1 के बाद. C is present first time after 1 at 1. C is at 1. D is at 3. E is at 4. F is at 5. So after 1, the first new character will come at 1. Next new character will come at 3. Next new character will come at 4. Next new character will come at 5. If you maintain this position vectors for any new index, you can do a lower bound and find when the new character is gonna come. So it is 26 log n. And that is why, my friends, in this question, you have characters instead of numbers. The same problem could have been asked for numbers, but then it would have been much harder because now you can have n different positions. Here you can maintain vector of position, vector int position for 26 different characters, and for all of them you will maintain at which positions you will be there, and then for each starting position, like if this is where you start your string A, C, C, D, D, E, F, E, D, F, ऐसे कुछ रहेगा. So even if you start over here, you will know that D is present at index 3, 4, and 6. E is present at 5. F is present at 7. C is present at 1 and 2. A is present at 0. So if you take this index 2, 0, 1, 2, 3. So 3, A is not present after 3. C is not present after 3. After 3, D is present first time. Next, E is present at 5. F is present at 7. So these are the positions where you will get the first distinct characters. E, F. Is this idea interesting already? Is how to find the first distinct characters? This idea itself is like one good problem. Okay. So this is another trick that you should kind of keep in your sleeve whenever you need this next time. Okay. Okay. So now, if I ever want to kind of change something, I'll try to change it in these kind of things only, such that I introduce more partition in it, right? So what will I do? I'll try to think about it in terms of DP now. Okay. From index number I want to make maximum partitions till n, given that DP of I comma 0 will tell I have not made the change as of now. DP of I comma 1 will tell I have made the change as of now. Okay. So if I have made the change already, is my answer for this fixed? If I already made the change and I have deleted that somewhere before, इज माई आंसर फ्रॉम आई टिल एन फिक्स्ड? और भाई इधर से ग्रीडीली करो, फाइंड द फर्स्ट, लाइक use that same logic, find the place where the cut will happen and you will get like where the k first k different characters come. After that you will not be able to take the k plus 1th distinct character. So from there onwards you have to solve again dp of that j comma 1 and इधर तो ले चुके हो. So dp of I comma 1 is easy to solve because if you have already taken, the answer is fixed going from I to n. Okay, dp of I comma 0, if you have not taken, there are two options. One is you will take that change in this current partition or you will do it in the next partition that will come later on. So if you do it now, you will think about how to make it optimal. If you don't do it now, you will have the choice. You have forced deletions कि यहाँ से कौन सा वाला delete होगा k plus 1 वाला character, and then उस पे you will call dp of j comma 0. And if you delete over here, then I'll have to think about कि अच्छा what will be the logic for that कि अच्छा अभी यहां से जो स्टार्ट कर रहा था मैंने पार्टीशन आई से लेकर के जो डिलीट होगा, इसी में मैंने कुछ चेंज कर रखा है. तो द चेंज हैज हैपेंड इन दिस पार्टीशन. सो व्हाट इज द मैक्सिमम नंबर ऑफ थिंग्स दैट आई कैन गेट इन दिस केस, राइट? एंड फॉर दैट आई हैव टू बिल्ड सम स्ट्रेटजी. आई हैव नॉट येट थॉट अबाउट इट, बट आई नो कि हो जाएगा इससे ही कुछ. ठीक है, दैट्स हाउ इन फैक्ट आई थिंक. समटाइम्स आई जस्ट लीव द फाइनल डिटेल्स टू द लास्ट पार्ट की कुछ तो हो जाएगा वहां पर सॉल्व. सो आई लीव दैट टू द फाइनल व्हेन आई रीच देयर. ठीक है, यहाँ तक डीपी आई हैव फॉर्मुलेटेड. नाउ टू फाइनली थिंक अबाउट दिस पार्ट, आई विल जस्ट बी एबल टू कि भाई यहाँ से सपोज सी डी डी ई एफ ऐसे करके कुछ है, एंड आई वांट टू मेक द चेंज इन दिस ओनली फॉर श्योर कि कुछ तो इधर ही चेंज करना है मेरे को इसी पार्टीशन में. सो आई विल ट्राई टू इंट्रोड्यूस, आई कैन इंट्रोड्यूस द चेंज इन एनी ऑफ द कैरेक्टर्स आई फील, है ना, कहीं पर भी कर सकते हैं. But then I will try to introduce the change ASAP, right? जितना जल्दी हो पाए उतना अच्छा. So maybe I will try to introduce the change at, let's suppose, somewhere over here at Z. First repeating character, yes, the first character that is repeating. I think introducing the change over there might be helpful क्योंकि हमें वैसे भी maximum partitions करना है, right? So I mean, on the worst case you can try every possible change कि भाई इस position पे जाके 26 possible changes कर लो, तो वो भी ट्राई कर सकते हो if you want to do it that way. नहीं तो फिर C will be taken and नहीं, I think that will not be the best way to do it. The best way, how do you do this the best way possible? कैसे करें कि भाई इसमें ही मुझे चेंज करना है, बट कहाँ पर चेंज करें ताकि ऑप्टिमली चीजें चेंज हो जाए इसके बाद, राइट? I will do it at, okay, let's suppose that, so what will happen when we change something कि हमें k तक लेना था, तो k प्लस अगला वाला कैरेक्टर कुछ नया आ रहा था, z आ रहा था कुछ नया जो उसको नहीं ले पा रहे थे k के वजह से, राइट? सो इफ आई इंट्रोड्यूस इट समवेयर देन इट विल ब्रेक अर्ली ऑन. ओके, सो what will happen is it will break at the k minus 1th position most probably क्योंकि उसके पहले कुछ चेंज कर दिया है मैंने. I think that is where it will change. अगर k तक ले पा रहे थे, कुछ नया कैरेक्टर को चेंज करेंगे कुछ किसी और चीज में, so it will stop at the k minus 1 because अब एक नया कैरेक्टर आ गया है यहाँ पर. So the final position is actually fixed. So I will just find the first non-repeating character and change it to something that I can, I would want it to be some new character जो इसमें present नहीं है, तो उसमें change कर दूंगा मैं. And I will always be able to find. If the value of k is equal to 26, तब तो सब कुछ ही एक ही सेट में आ जाएगा, right? So if it is not equal to 26, if k is not equal to 26, then in the first 25 different characters, I will always be able to find one character that is not present, no, जो यहाँ पर था, तो मैं उसको उसमें इंट्रोड्यूस कर दूंगा ताकि first k minus 1 में ही चीजें रुक जाए, and then I will get more options over here, and that is how we will do it for the rest of the characters. तो first जो repeat कर रहा है उसको replace that character with something that is not present in the first k thing. That will be a good strategy to do for this, and then you will obviously get into a db transition based on that, and that is what will lead to a solution. क्योंकि तुम if you change anything to something that is already present, then it will not change the thing, no, it will not change our answer. That is as if we have ignored that. तो बस उसको लो, change करो and see if you can get into a good place. ठीक है, so find the first non, like two ways. One is इस पार्टीशन में चेंज होगा ही नहीं, तो 26 डिस्टिंक्ट कैरेक्टर निकाल के फर्स्ट कहाँ k प्लस 1th वाला नया कैरेक्टर आ रहा है उसके आगे डीपी सॉल्व कर दो, एंड यहाँ तक का जो फिक्स्ड कॉस्ट है वो तो एक पार्टीशन हो गया, 1 प्लस डीपी ऑफ दैट. If you find that you want to use it in this partition, then find the first non-repeating character that exists in this particular case. First repeating character, sorry, non-repeating, first repeating character, and replace that particular character's first या second occurrence, किसी को भी change करो, फर्क नहीं पड़ता, with something new that isn't in that partition, जो first के में नहीं आने वाला था. तो उससे क्या होगा, थोड़ा सा पहले जल्दी खत्म हो जाएगा ये, क्योंकि वही था ना, जैसे A C C C A था. So we replace the first, जो इसका जो first repeating वाला character का जो occurrence था, with something that is not present like B. तो उससे क्या हुआ, ये जल्दी खत्म हो गया. And then you had to solve this much portion with a new character. So वो चीज हम अलग से solve कर लेंगे, right? That is what will happen. ये distinct वाला example मतलब समझा नहीं, कौन सा वाला ट्रिक जो आपने बताया? अच्छा, वेक्टर मेंटेन करने वाला कि हम लोग कैसे निकालेंगे कि कहां पर फर्स्ट कट होगा 20 ऑर्डर 26 में. Yes, so what will we do, like if we make a cut, if we know that we will make a cut, so we will make it at the first non repeating character from over here, dp of I, 0. मतलब अभी तक हमने कट इसके पहले जो फोर्सफुली करा था सब, यहाँ पर हमने अभी तक यूज नहीं करा, अब यूज कर लिया. So I will know where I will stop, from here also I will know where I will stop, ठीक है. And then from there onwards it's the original array only, so I will be able to use dp of जो भी जहां भी खत्म होगा ये चीज, j, हमने यूज कर लिया अब. This is what we will do. And how do you find कि भाई मेरा कट्स कहां पर होने वाला है? So if you have a c c a c a इस टाइप का, ठीक है, and I have to make k equal to, and I will add more characters d इस टाइप का कुछ, ठीक है. So I will maintain a is present at index 0. Yes, it will be till k minus 1 distinct characters plus 1. No, not plus 1. Where will be the k? Wherever we introduce that, okay, we'll have to see where the k plus 1th change will happen. K plus 1th next character will appear. It will be exactly at the place where the kth new distinct appears. I'll show you how to do this. Suppose a is equal to 0, c is present at 1, 2, 3, a is also present at 4, b is present at 5, d is present at 6, ठीक है. So let's say we check over here, ठीक है, at the starting 0 से check कर रहे हैं. तो देखो फर्स्ट डिस्टिंक्ट कैरेक्टर कहाँ आएगा, 0 पे. नेक्स्ट डिस्टिंक्ट कैरेक्टर कहाँ आएगा, 1 पे. आई मीन मैं सब पे जा रहा हूँ, आई एम गोइंग थ्रू ऑल एंड आई एम फाइंडिंग वेयर द फर्स्ट डिस्टिंक्ट कैरेक्टर फॉर ऑल ऑफ देम अपीयर्स एंड सॉर्ट इट बेसिकली 5 and then 6. So I can get that the 4 distinct character from over here, first, second, third, fourth. Everybody agrees that we can find it from the vectors over here. Okay. Now, assuming that I can make like 2 different characters in one, if I don't make a change over here, I will get to this particular state की dp of by 5 के आगे कुछ भी change करके बनाओ answer. That is like a recursive case. The interesting thing is, what if I will change in the first partition itself, right? In that case, what I will do is I will look at what is the first number that is repeating. I will see, ideally I would have closed over here, ठीक है. फर्स्ट डिस्टिंक्ट मेरे को यहां मिला था, सेकंड डिस्टिंक्ट अगर 2 डिस्टिंक्ट तक लेंगे तो मैं यहां जा सकता हूं. फर्स्ट डिस्टिंक्ट मैं यहां तक ले सकता था, ओनली 1 डिस्टिंक्ट. 2 डिस्टिंक्ट आई कुड हैव टेकन ओवर हियर, ओके. बट नाउ इफ आई मेक द फर्स्ट जो रिपीट हो रहा है, राइट, उसको अगर एक कुछ नया कैरेक्टर लाइक z से रिप्लेस कर दिया, सो आई विल बी ओनली एबल टू गो टिल अ सर्टेन पॉइंट, ओके. फर्स्ट रिपीट कहां पर हो रहा है, यहां रिपीट हो रहा है ना फर्स्ट टाइम, राइट. आई विल ओनली बी एबल टू गो टिल अ सर्टेन पॉइंट कि भाई यहां पर तक मैं, तो अब 2 यहां तक होगा, यहां तक 3 होगा, एंड देन इसके आगे देखो 4 सेम जगह पे हो जाएगा जहां पर पहले 3 था. हाँ, the 4th will be over here. So till 3 I can go over here now. Earlier I was able to go till 2 over here. 2 distinct characters till this much. Now it will become 3. And 2 will become at the place where I have introduced the new thing. Okay. So that is what we will now check, that in this first character that is getting repeated, where like you make a change in such a way that your first remains over there itself. Second becomes just before the position where like you have introduced a new character, because it will change, it will make the partition end faster. And then the third will kind of continue from there onwards. Okay, so we'll find the first character which has a repeating origin next, and then we will possibly replace it with a new character which is not present in this, क्योंकि k का value 2 है तो कुछ ना कुछ तो यहाँ पर जो present है, I can replace it with d also, because d तो यहाँ available ही नहीं है, so it will be unique character only which is not present in this. Okay, I'll replace it with that. If the first k are not repeating, then no need to change, right? No, if nothing is repeating, then all the string will be get covered. No, कहीं तो repeat करेगा तभी तो रुकेगा, repeat होगा नहीं तो रुकेगा, partition कैसे होगा, फिर तो पूरा एक partition बन जाएगा, right? That is how you will do it. Okay. There's like, this is a harder problem. I can feel this कि ये थोड़ा मतलब both implementation wise and thinking wise would have been harder. And I think even if you're thinking of internships and coding tests, this will not come in tests and all. But then this is how you think about कि DP, क्योंकि partition करना है तो DP सोचेंगे, right? How to find the next distinct faster, like where will be my kth distinct character? That is, how do you find that faster? I just told you that idea. And then now with that you can do these things in faster than O of n transitions, कि भाई कहाँ तक कट होगा वो फटफट मिल जा रहा है मुझे फॉर्चुनेटली, right? Did you get this idea what I talked about? ये फर्स्ट दो आइडिया सीखे तुम लोग, जो मैंने दो आइडिया बोला? So please implement this one. बहुत मेहनत है इसको implement करने में. Can do this, but then this will be fairly fair. This is hard implementation too. I'm thinking if I should take this up and this or not. It will become pretty large. But then let me think for it. Okay. So basically, you use the operation in a way to cut the current prefix as soon as possible. Okay. I'm just thinking one thing. The A, C, 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 D, 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 कुछ ऐसा E, E, F ऐसा कुछ रहा. And like you have like you can take 3 characters, okay? So if you want to introduce it, do you want to introduce it over here, or do you want to introduce over here? I think it will be always optimal to introduce it over here, क्योंकि यहाँ पर 2 में यहाँ बंद हो रहा था, 3 में यहाँ बंद हो जाएगा, and then you will have more choices afterwards. The choices कुछ बचेगा नहीं. Take this only, so you will have much better choices afterwards. इसके बाद. It's always better to do it this way. This is hard implementation here. This is hard implementation. You'll have to write so many new things. It'll easily take us time. It'll take us 20 minutes, I think. 15-20 minutes to explain everything, and like code will take 15 minutes at least to do it properly. भाई कहाँ पर change करें and so on. All these things. There's a good amount of nuances. Okay. When the first repeating character, change the next character to something that is not present, that is farthest in the string basically after it, and then process it from there onward. Okay, that is the main idea to do this. I'll refrain from implementing this in the live session because I feel this is fairly difficult to for you guys to solve it in a competition. Matlab, it will take me 20-25 minutes to code this. So I can think that this is fairly hard. Okay. So we'll skip this for implementation. I think this is a fairly hard problem. Learn the idea. I can show you from some implementation. No? That is also an option. किसी का implement देख के कर बता देता हूँ. Because it will take me 20 minutes to implement this. Okay, let's take somebody's implementation. कहाँ गया भाई? Leaderboard कैसे देखते हैं? More. Yes. Question number 4. Python में लोग क्यों implement कर? देख रहे हो घटिया implementation लोगों का. ये तो मास्क ही डाल दिया इसने. बिटमास जीपी नहीं 26 में बिटमास जीपी कैसे करेंगे? बहुत ही घटिया implementation. See, everybody has done that कि next character कहाँ पर present है वो maintain करने का and then कुछ वही बोला ना गंदा implementation है. सब बग खाए एक बार. बहुत ही गंदा क्वेश्चन दिया है. Yes, this is hard problem. ठीक है, this is fairly hard problem. So we can skip it, no problem. सब कुछ गंदा कोड दिख रहा है मेरे को. अच्छा कोड तुम लोगों को समझाने लायक नहीं कोड दिख रहा है. रे बाप क्या सब लिख के रखे लोग. भाई नहीं हुआ ये सब. ये तुम नहीं समझा पाऊंगा मैं तुम लोग को. It'll take me much more time to explain this one problem. There are hard problems, right? Like no matter how much I try to explain it fully, it will take very long time. So we can skip that part थोड़ा सा. ये क्वेश्चन अगर तुम लोग skip कर दोगे तो it will not hurt you. पर वो ट्रिक समझ में आ गया. वो नेक्स्ट कैरेक्टर निकालने वाला. That is important. That is something that can come up in a coding test or an interview also. So you should know that trick. That you maintain vector of all the positions and then use that to find the quickly where all the distinct characters are available. Where is the first character? Where is the next C? Where is the next A? And so on. You can use lower bound to find that out. And that's a very good idea actually. Okay. With that, I think we'll stop for at least today's session. I mean, in terms of the discussing this, right?